Good, good morning, friends and students. Today, in this e learning program, we are going to learn about types of bonding. So, before going to the types of bonding, we should know about what is bonding or what is bond. Bond. This is the force of attraction between two atoms in a molecule or in a crystal is known as chemical bond or bonding. So, the force of attraction between two atoms in a molecule or in a crystal is known as chemical bond or bonding. Now, why these atoms needs bonding? Why atom form bonding? To understand this, first of all, we should know about the basic parts of the atom. If I will take an example of beryllium from periodic table, beryllium, it has 4 atomic mass and 4 atomic number and 9 atomic mass. So here it consists of this beryllium atom consists of protons, electrons and neutrons. So what is proton? It is subatomic particle with positive charge. So here in an atom of beryllium, number of protons is equal to 4. Next come electron. This is also a subatomic particle with a negative charge. Usually in an atom, number of electrons is equal to number of protons with a difference of negative charge. So, number of electrons in beryllium will be 4. Third part is neutron. It is a subatomic particle with neutral charge. So, as we know that with simple mathematics, protons plus neutron, it gives atomic mass. So, in an atom of beryllium, number of protons are 4 and we don't know the number of neutrons. Have to find it out with simple mathematics. Here the number of neutrons will be 5 in a beryllium atom. Now, these proton and neutron, they form an electron cloud for beryllium atom. And electron, they will split up or they will take place different energy levels of beryllium atoms. We will see like this. This is the nucleus of beryllium. This consists of proton plus neutron. This is first energy level. This is second energy level. So, as beryllium has 4 atomic number, 9 atomic mass and number of electrons are 4. So, according to electronic configuration, so number of electrons splits up into 2 and 2. So 2 is in first energy level, this is first energy level, and another 2 is on second energy level. Beryllium. Now, to get a stable configuration or atom to be stable, the outermost electron must have 8 electrons so that it can go with octet rule. So this is valence shell, and these are valence electrons. So the outermost part of an electron cloud contains valence electrons, that is called valence shell. Maximum number of electrons in a valence shell will be 8. So, an atom will be stable only when it has 8 electrons in its outermost shell. To attain this octet, atoms have either to lose or gain the electrons. So, atoms that form bond with other atom by sharing or transferring the electrons is known as octet rule. Now, The strength of bond depends upon the molecules or atoms involved in the process. So based on this, there are three types of bondings are there. First is ionic bond or bonding. Second is covalent bond. And third one is van der Waals bond. So first we will discuss about ionic bond. What is ionic bond? So ionic bonds are the bond formed between the two atoms by complete transferring of an electron in a molecule or in a crystal. That is known as ionic bonding. For example, if I take sodium chloride, a compound, from periodic table, sodium has 11 atomic number and 23 atomic mass, and if I will go with its electronic configuration, the distribution of electrons in different energy levels will be 2, 8 and 1, and for chlorine it has 17 atomic number and 35 atomic mass. With its electronic configuration, the distribution of electrons in different energy levels will be 2, 8 and 7. So if I will draw like this, this is the nucleus which contains protons plus neutrons of sodium. This is first energy level, this is second energy level, and this is third energy level. In first energy level, it contains 2 electrons. In second energy level, it contains 8 electrons. And in third energy level, it has only 1 electron. So now, it needs 7 more electrons to complete its octet. To make the sodium atom stable, it needs 7 more electrons. If we will take a chlorine, it is a electron, proton plus neutron, first energy level, second energy level, third energy level. Here in first energy level it has 2 electrons, in second energy level it has 8 electrons, and in third and outermost energy level it has 7 electrons. Now it needs more number of electrons to get stable, and this electron needs only 1 electron to get stable. So what will happen? Sodium will give its 1 electron or transfer its 1 electron to chlorine. So this electron comes over here. It transfers. Completely transferred. So when it transferred, what will happen? Outermost shell becomes unfilled, but other two shells become energy levels become filled. So this atom now it becomes sodium ion with plus charge, and I will later on tell you about plus and negative charge about it. So it becomes stable. Now here the outermost shell also complete with the transfer of one electron from sodium to chlorine. Now it becomes stable and it has followed the octet rule. So it becomes chlorine negative. Now I will tell you about positive and this negative charge. When an atom gives or lose its electron to other atom, it becomes cation with a positive charge. So in this example, sodium gives its one electron to chlorine, so it becomes sodium plus. So here it gives only one electron, that is one only. If it gives 2 electrons, you can write it 2, or if it is give 3 electrons, you can write it plus 3 like this. And an ion. If an atom gains an electron from other atom, it becomes negative. Becomes an ion with negative charge. So in this example, chlorine becomes negative with one charge because it has take only one electron from sodium to get stable. If it gets more 2 electrons, then here it will be 2. If it is get 3 electrons, then here it will be 3 like this. But when it is gaining some electrons, it will get in a form. It will comes in the form of anion. So it will be a chlorine anion or chlorine ions. Now we will see how the strength of these ionic bonds affected. Factors affecting ionic strength of ionic bonds. First one is ionic charge. Higher the charge, stronger will be the bond. As number of charges, as I told you, Na +1, +2, +3 like this, or chlorine -1, -2 like this. If the charges increases, there will be a the bond will be stronger. Second one will be ionic radius. Here, larger the radius, weaker the bond. How? The charge, as radius increases, what happens? The charge spread over a large surface area. Charge spreads over a larger surface area, resulting in weakening of ionic bonds. Now we will see the physical properties of ionic bond. Physical properties of ionic bond. First one is the compound formed with this ionic bond are known as ionic compounds. So these compounds have high melting and boiling point. So as these compounds are formed in the form of crystals, these are solids. So solids are packed together, and to separate these ions, so they need a lot of energy to separate the ions. That is why they have high melting and boiling point. For example, magnesium oxide, it has high melting point, so that is why it is used in refractories as a heat resistant material. Second physical property of ionic compounds are they are soluble in water. How? Let there is a two hydrogen atoms like this. One hydrogen, it is oxygen. It has a very slight negative charge is there. So the electrons in water molecules are not evenly spread. As you can see, this is oxygen. They are not evenly spread. So one end of the molecule is slightly more negative as compared to the other ends. So these water molecules attracted towards these water molecules attracted towards these ions pull them out from the packed structure. So the compound dissolves in the water. So the compound dissolves in the water. And third property is electrical conductivity. When they are in solid or crystalline form, they are not able to conduct electricity. But when these compounds are in molten state, what will happen? The ions are free to move. When ions are free to move, they conduct electricity from them. So that is why in molten state, ions are free to move. Ions are free to move and they are able to conduct electricity because the crystalline lattice broke down and ions can move. Now comes to covalent bonding. This type of bond is formed between the atoms where electrons are shared. So, this type of bond formed between the atoms where electrons are shared. For example, I will take oxygen atom. It has a 2 atom. So let in periodic table one oxygen atom has 8 atomic number and 16 atomic mass, and another oxygen atom has 8 atomic number and 16 atomic mass. Now the electronic distribution of electrons in different energy levels will be 2 and 6, and likewise here also 2 and 6. If I draw energy levels and show the distribution of electrons, it is like this. It is oxygen 1, this is oxygen 2. So this is the first energy level. Here the number of electrons in second energy level. The same is here also. First energy level in second energy level. In first energy level we have only 2 electrons. So now the first energy level or innermost energy level becomes stable. Now come to second energy level. It has 6 electrons. 1, 2, 3, 4, 5, 6. So likewise here 2 electrons in first energy level, in second 1, 2, 3, 4, 5 and 6. See, both the atoms in their outermost energy level or valence shell, they contains only 6 electrons. And both are not stable. To become stable, they both need 2 electrons to complete its octet and become stable. For this, what they will do, they will share 2 electrons with each other to become stable. So here sharing of 2 electrons from this oxygen atom and 2 electrons from this oxygen becomes sharing, and they form a stable oxygen atom. When they will share, as it is a sharing, so energy, the movement of electrons, sometimes it is more in this oxygen number 1 and sometimes in another oxygen, and it will move. So because of this is little bit weaker bond as compared to the ionic bond. Now we will come to the factors which affects the bond strength of covalent compounds. Factors affecting strength of covalent bonds. First one is bond length. What is this bond length? Bond length is nothing but it is the average distance between nuclei of two atoms which form bonding. So, as bond length as bond length decreases, the strength increases. For example, hydrogen. Hydrogen has to share only one electron with other hydrogen atom. So, the bond length between them will be very high. And oxygen, they have to share two electrons. So, the bond length becomes a bit reduced. And in case of nitrogen, they have to share 3 electrons. Now in this case, as you see, as bond length decreases, the strength of covalent bond increases. Second factor which affects the strength of covalent bond it has only one factor which affects the strength of covalent bonding. Now we will see the physical properties of covalent bonding. First, in contrast to ionic bonding, they are less stronger than ionic bonding. Second, they have low melting and boiling point. Third one, they are not soluble in water. The compound formed with covalent bondings are not soluble in water. And fourth, they do not conduct electricity. Now we will come to third type of bonding, that is van der Waals bonding. What it is? Van der Waals bonding. is a kind of bonding which is very weak in contrast to ionic bond and covalent bonding. Second point, this type of bonding is found in all the materials, but as ionic and covalent bonds are stronger than these van der Waals bondings, so these bondings overshadow by ionic bond and covalent bonds. Third point, these kind of bondings are not formed by the transferring, donating or sharing of electrons. Fourth point, they are formed when an uneven charge distribution occurs. Means when uneven charge distribution occurs, it means there is a formation of dipoles. Point, these dipoles can be produced by a random fluctuation of the electron around what is normally an electrically symmetric field in the atom. So, till here in van der Waals bonding, what we have gone through, these bondings are very weak in contrast to ionic and covalent bonds, as these van der Waals bondings exist in all the materials, but due to the high strength of ionic and covalent bonding, they are overshadowed by these two bondings, means ionic and covalent bondings. So these van der Waals